On this presentation, we would like to introduce you to the E-Golem project, which is dedicated to the creation of a new kind of digital textbook with a simulation model in the background, executable in an internet browser on any device, computer, tablet or smartphone, on any operating system. In the 5th century BC, the wise Confucius noted, "I hear, I forget, I see, I remember, I do, and I understand." After more than 2,000 years, in the 17th century, the founder of European pedagogy, John Amos Comenius, supported the principles of active teaching in his books. In books, as well as in his teaching practice, Comenius strove for active, playful teaching. Confucians' experience from ancient China and Comenius' effort to playfully teaching confirms modern active teaching methods widely using simulation games and simulators. Simulators are a very effective teaching tool in many fields, for example in training pilots. They make it possible to practice work procedures in virtual reality and acquire practical habits that have taken much more time in actual reality. Like flight simulators, medical simulators allow an entirely new way of teaching, where a student can practice diagnostic and therapeutic tasks in virtual reality without danger to the patient. Simulators automatically respond to the administration of drugs and various infusion and respond to the settings of connected medical devices such as anesthesia equipment, artificial ventilation, artificial kidney, etc. Despite the development of electronic readers, classical textbooks have not lost their meaning. Many modern textbooks have accompanying electronic material, including an electronic version of printed book, animated images, multimedia, and other resources. However, the development of the Internet fundamentally changes the possibilities of contemporary electronic learning. In addition to hypertext and multimedia, teaching materials may include simulation models. Simulation games offer new opportunities for explaining the complex interconnected systems of the organism, their behavior in norms, and in various pathologies. The simulation model on the background of the interactive picture allows for a more straightforward explanation of causal relationships and contributes to a better understanding of the mutual context of the explaining processes. A tablet with an internet browser no longer has to be just passive display of printed text in a textbook. Any devices with an internet browser is enough to work with an interactive simulation textbook. Nothing needs to be installed. Today's internet browsers have the computing capacity of desktop computers in the 90s. In browser simulations can use this capacity with interactive illustrations linked to a background simulation model. This way, we create a new type of electronic digital textbook, executable in a web browser, which we could call interactive simulation textbooks. Interactive simulation textbooks expanded the possibilities of classic digital textbooks. In addition to hypertext, multimedia, and interactive graphics, they contain a hidden hidden simulator in the background. The outputs of the simulation model can be displayed as graphs, and the simulation model can also be controlled by interactive graphics. The images can thus appear as a kind of puppet controlled by a model in the background. Creating interactive simulation books is not easy. It requires multidisciplinary cooperation. Interactive simulation textbooks combined study text with a simulation model and interactive graphics. The artist creates interactive pictures, and the modeler creates simulation model behind the background simulation games. Simulation models can also control animated images, animated graphics, figuratively speaking, hang on the threads of simulation models like puppets in a puppet theater. The key is the educator, who formulates the study text and conceptual design of the whole simulation textbook. An important person is a programmer, whose task is to stitch the whole application together. The fundamental problem is to create a tool that will allow the four professionals to work together and link the results of the four professionals into a single textbook. This tool is our BodyLite technology. This technology is based on new standards and new technologies that have been adopted in recent years. The artist creates interactive animations using software tools for creating interactive graphics, such as the Adobe Animate tools. The result is an animated image made in JavaScript and HTML5. Modeler creates mathematical models using equation-based modeling language. Equation-based languages allows us to describe a model using a set of equations. Finding the algorithm of their solution is the task of compiler. We use a standardized equation-based language, Modelica. Modelica language was initially developed in Sweden. The Modelica development environment is available both in an open source version produced by Open Source Modelica Consortium and in several commercial implementations, such as Daimola by Dassault Systems or System Modeler by Wolfram. The result of the program translation from the Modelica language is the source code of the simulation models in the C programming language. New standards for web browsers have been agreed upon in recent years. The HTML5 standard brought animation canvas for displaying moving images. JavaScript capabilities have been enhanced using ECMAScript 6. Another standard is a low-level language for Internet browsers called WebAssembly. Modern browsers have been built-in tools that understand the source code of WebAssembly, which leads to a significant acceleration of code execution. Thanks to WebAssembly, browsers can perform extensive numerical complex simulation calculation. The Web Component standard allows us to create reusable web components as a new HTML element. Another standard is Function Mockup Interface, FMI. FMI standard allows the interconnection of simulation models. The Modelica compiler, according to this standard, generates the source code of simulation models in standardized form of so-called function mockup units. In our technology, the source code of the simulation models compiled into FMU units is transpiled into WebAssembly and JavaScript. Adobe Animate generates interactive graphics into HTML5 and JavaScript standards. In our technology, we transport interactive graphics into reusable web components. The educator creates a conceptual application design. The graphic artist creates interactive images and uses tools such as Adobe Animate to compile them into JavaScript and HTML. Then we use our BodyLight tools to create a standard web component. The modeler creates a mathematical model in the Modelica language. The Modelica compiler generates C source code according to FMI standard as a function mockup units. Using our BodyLight tools, we recompile the model's source code into WebAssembly and JavaScript, and then into the model web component. The programmer creates a library of interconnective web components as a tools for developing applications. We create learning application from a library of web components as from Lego cubes. The output is a generated web simulation application in HTML, JavaScript, and WebAssembly. We can run the developed application in any internet browsers on any device. Our interactive design tool supports the collaboration of educators, modelers, artists, and programmers in created web-based learning simulators. The result is simulation tutorials that can be run in web browsers on any device, on computer with different operating systems, or on a tablet, or on a smartphones. Finally, here are a few examples. This is an example from tutorial dedicated to iron metabolism. The animated image, controlled by a background model, represents a duodenum cell. The interactive model allows you to observe what happens during various iron intakes in the diet, bleeding, or after a blood transfusion or infection. Another example is a sample educational application explaining the function of the nephron. An interactive model-driven picture of the glomerulus leads to a better understanding of the context in the accompanying text. This picture shows how changes in arterial pressure resistances in afferent and efferent arterioles, or changes in the filtration coefficients, affect glomerular function. The last example is an example from the hemodynamics tutorial. We can observe how to change left heart pressures and volumes and pressure-volume diagrams of the left ventricle with changes in frequency or changes in inotropy. A critical prerequisite for developing educational simulators is a creative connection between professionals, an educator, an artist, a creator of mathematical model, and a programmer. But at the center of everything is the student, and student feedback is essential. Therefore, students become full members of multidisciplinary development team. We teach more than 160 students from Israel at our faculty. A group of IT students from Israel is also interested in our body light technology. The E-Golem project is an initiative that arises from the enthusiasms of volunteers, Czech and Israel students, teachers of the Faculty of Medicine, and the spin-off company Creative Connections. By the end of the year, we want to create several educational web simulators. Web-based simulation textbooks will make in Czech, English, and Hebrew. In summer semester, we will try it out in medical education at the first Faculty of Medicine. We will also try to test them in teaching at the partner medical school in Israel. In the spring of next year, we will organize a workshop for IT students from Israel in Prague, where we will teach them how to use our body light technology in creating interactive simulation digital textbook. The E-Golem project is based on shareable scientific results, mathematical models of physiology. We have been engaged in the mathematical modeling of physiological systems at our faculty for decades. The second pillar is our new open source body light technology for creating web simulators. The created web simulators are copyrighted work and have significant commercial potential. Web-based simulators materialize interdisciplinary cooperation and the results of scientific research, the creation of mathematical models, into a commercially saleable product. Interactive simulation textbooks are modern realization of old Confucian wisdom and implementation of comenius effort for playfully teaching. Interactive simulation textbooks are real schola ludus for 21st century. We are looking for collaboration to develop body light technology. We are looking for collaboration to exploit and create interactive simulation textbooks in E-Golem project. Thank you for your attention.